This video is going to serve as your lecture notes for the week and also give you the information you need to complete your homework assignment. So we're going to start with the structure of the atom. We've already gone over the basic structure of the atom, but you have a picture here of an atom, and in the middle is the nucleus, and then the outside is the electron cloud where all the electrons are circling around the nucleus. In the nucleus you have protons and you have neutrons, and then on the outside you have the electrons. And if you look at this, the electrons, when you're writing them, you're going to write them as a lowercase e superscript negative. And that's to indicate that it has a -1 charge and its mass is 0, and that's because the electrons are so small that their mass is negligible. We just put that as a 0 mass. They're not heavy enough to count as anything. And you find them in the electron cloud. So this is the electrons. Then in the nucleus you have the protons, and when you're writing out the symbol for proton, you're going to put lowercase p with a superscript plus. That's to indicate that it has a +1 charge. It's a positive charge. And when you're writing the mass number, it's 1 AMU, which means 1 atomic mass unit. And that's how you label it when you're putting the weight of it. You need to make sure you put this as the label. And those are found in the nucleus. And then last you have the neutrons, which are here in the nucleus as well. When you're writing it, you're going to put it as a lowercase n superscript 0. That's to indicate that it has no charge. It's neutral. It's not positive or negative. And its mass number is 1 AMU, 1 atomic mass unit. It weighs 1. And those are found in the nucleus. When you look at the overall charge of an atom on a whole, an atom is generally neutrally charged, and that is because you have the negative electrons that are flying around here and the positive protons that are in the nucleus. So the positive and the negative cancel each other out, and overall it's a neutral atom. And every time you see this atom presented on a periodic chart, the way it's presented on the periodic chart is always going to be neutral. There are times when atoms will be positive or negatively charged, but when you're looking at it in the generic form of the atom on the periodic chart, the atom's going to be neutral. However, the nucleus is always positively charged. And the reason for that is because you have all these protons and all these neutrons. The protons are positive, the neutrons are neutral, so there's nothing canceling each other. So the protons take over, and it's a positive charged nucleus. So neutral atom, positive nucleus. When you're looking at most drawings of an atom, they're not to scale. And the reason why is because the nucleus is in the middle, but it's tiny. And the electron cloud that goes around the whole outside is huge. It actually comes all the way like around here. But it couldn't be drawn to scale because you usually don't have enough room to draw it. So you need to know that the nucleus is here, and then there's a whole bunch of space here, and then the electron cloud starts. The nucleus contains almost all of the mass of the atom, so it's super, super dense. It's heavy. It's the part that takes up almost all the weight, the mass of the atom. However, the electron cloud is where all of the space is, so all the volume. So the volume is in the cloud, but the mass, the weight, is all in the nucleus. The nucleus is very, very dense, it's heavy. The electrons don't weigh hardly anything, but they take up the most space. If you were looking at it like an analogy to get an idea of what an atom looks like, you can imagine a football field, and right in the middle of the field would be a tiny bee. Not even a big picture of a bee like this, but an actual real bumblebee, just right in the middle of the field. That would be the nucleus. Then all this space would be the electron cloud. And this first ring right here would be the first valence of energy, the first orbit. And right out here would be a grain of sand, and that would be the first electron. So you have a little tiny bee, all this huge space, and then the electron is equal to the size of a grain of sand. But it's never drawn that way because they don't have space on a piece of paper to draw it to scale. So when we're looking at an atom, we have to wonder, how do all of these pieces stay together? Why don't these particles just fly apart and just break apart? How do they stay together? And they stay together because of two forces. We have electromagnetic force and you have nuclear force. And we're going to talk about each of those. And that's really important to know, especially for a test, is what holds this atom together. So the electromagnetic force is what keeps these electrons attached to the nucleus. And the nuclear force is what keeps this whole entire nucleus from busting apart, okay? The electromagnetic force is saying that when you have like charges, a plus and a plus, or a negative and a negative, they want to repel each other. They want to push away from each other. So when you're playing with a magnet and you feel those two plus sides going together and that you can't push them together because you feel that tension, that magnetic repel in the middle. Well, what happens with an atom is you have these electrons which are negatively charged and you have these protons that are positively charged, and they pull towards each other. So the electrons are always trying to pull towards the protons are trying to pull towards the electrons, and it keeps this whole unit connected. They're all attached because of the electromagnetic charge. However, then you look inside the nucleus and you would say, well, if that's true, you have all these protons and they're all positive, they should be repelling each other and busting apart from each other. But it falls under a category of nuclear force, which says that if the protons are very, 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 very close to each other, they'll create a strong nuclear force, which is actually kind of acts like a glue. It's 100 times stronger than the electromagnetic force, this nuclear force that holds all these protons together in a little ball. So if you were asked what keeps the atom together, you have the electromagnetic force, and be able to explain that, and then you have the nuclear force, which is what's going on in the middle with all the protons. Okay, this is just a silly cartoon to remember what nuclear force is. Okay, so we're going to practice what you would be doing in your homework. In your homework, you're going to be given an element, how it would appear on the periodic chart. And you're going to need to fill out its atomic number, its atomic mass, the mass number, the number of protons, the number of electrons, and the number of neutrons. So going through this, let's go this step by step. So the atomic number is the number that's always going to be found up here. And this is the number that is unique for this element. So there's only one number 17, and 17 is always chlorine. What the atomic number indicates is the number of protons and the number of electrons. So in this atom, it has 17 protons and 17 electrons. Okay? The atomic mass is this number down here. And what that is it's saying it's the average, so that's why it's always a decimal. It's the average number of protons plus neutrons. And there's isotopes, we'll talk about that in lab about why you would have different, but that's why this number is not exact. Excuse me. So the atomic mass is the number of protons plus neutrons, but it's an average. So they take a bunch of chlorine atoms and they come up with what's the average weight of them all. That is a little bit different from the mass number. And what the mass number is they round this to a whole number, which would be 35. And basically what you're saying is there's 35 things, there's 35 protons and neutrons inside of the nucleus, and that's going to be a whole number. So if you know that there are 17 protons and the mass number is 35, and this is what's in the nucleus, you have 17 protons in the nucleus. How many neutrons do you have in there? You take 35, you subtract 17, and so you would end up with 18 neutrons. Okay, so checking it, we have 17 is the atomic number, 35.45 is the atomic mass, which is the average. The mass number is rounded to a whole number. Protons, 17. Electrons, 17. Neutrons, are going to be what's in the middle minus the protons. Okay? Let's just go over this one more time really quick for your homework. So, like we said, atomic number is up here. It's the number of protons and the number of electrons. It's unique to every atom. So if I said to you, what is the name of the element that has 23 electrons, you should be able to tell that just by based on the number. Every element has its own unique atomic number. And then when you're looking at atomic mass, that's this number down here, which is the average mass of an atom. Not to get confused with the mass number, which is when we would round this to 12 and say this is the number of protons plus the number of neutrons. Is how many things are in the nucleus. Okay, and by things I mean protons and neutrons. Okay? And I think that's it. We won't even go on to this. So that's the information you're going to need to do your homework. Please take notes on these lectures, on this lecture. Keep it somewhere because it will be included in your Unit 2 test. This video could be found on your chemistry assignment page at the very top underneath chemistry resources, and you can use that for studying for the next test. And you'll need all this information to complete your homework this week. All right, I'll see you at lab.